Today will be ECMO circuit part 3. As a part of ECMO circuit, we should have monitoring for ECMO circuit. So we will see how can we monitor the ECMO circuit in this lecture. The monitoring will include function, efficacy, and the detection of any harm. If we start to monitor the function, so we need to know the flow and pump ramp, which means the speed, circuit pressure, the efficacy of the circuit, including circuit blood gas, oxygen saturation, and detection of any harm from the circuit like coagulopathy, hemolysis, air embolism. The first important part in the circuit function is flow monitoring. As we know, centrifugal pump is preload and afterload dependent, so the flow can correlate with the circuit and cannula size. It can be applied externally, direct on the tubes, or incorporated into a machine, inside the machine. For a given RPM, which is reflecting the speed, any increase in post-pump resistance will cause decrease in the flow. So the example for decrease post-pump resistance like kink or clot in the returning line, or increase in mean arterial blood pressure in VA ECMO. This video show alarm of decreased flow, and this is parameters for pediatric patients. As a part of function of flow meter, ultrasonic flow meter can detect air bubble in the circuit. It can sense the normal change of the blood or interruption of this normal blood flow. So as in this picture there is air, so there is interruption of the blood flow. At that time there will be trigger alarm automatically to stop the flow. Bubble detector can put in the arterial limb or venous limb of the circuit or both of them. This video show alarm for air detection. The flow starts to decrease, then will stop till it be managed. The most important part in the circuit function is circuit pressure monitoring. As the pressure should be measured continuously, it can be measured directly or indirectly. In the circuit, we have three pressures. The first one is P1, which is pre-pump pressure or drainage pressure. It's usually negative pressure. The second one is P2, which is pre-oxygenator pressure, which is positive pressure. The third one is P3, which is post-oxygenator pressure. The second most important part in the circuit monitoring is circuit pressure monitor. First one is the pre-pump, which is P1 negative pressure. The second P2 pre-oxygenator and post-pump. And the third one is P3 post-oxygenator pressure. P1 is a negative pressure, which is a non-touch zone. We can't open the circuit in these parts, ranging from -50 to -100. It will come increasing more in hypovolemia or if there is inflow obstruction like cannula or line kink, or increase intra-abdominal and intrathoracic pressure. Second pressure is pre-oxygenator positive pressure. It ranges from 250 to 300 millimeter mercury. Increased pressure will occur if there is resistance or obstruction distal to the pump in the return line or return cannula. In the oxygenator will increase this pressure. Third part is P3, which is post-oxygenator positive pressure. It's less positive, 200 to 300. Increase the resistance or obstruction distal to the oxygenator. For example, return line or cannula. Increase the return vessels pressure in VA ECMO like hypertension. Why we monitor circuit pressure changes? As any increase in pressure in the circuit will increase the resistance, So it will lead to ECMO flow fluctuation. Another issue where there is non-physiological negative pressure or increase in negative pressure, which is P1, that will lead to blood cell damage. And blood cell damage will lead to increased hemoglobin, free hemoglobin, which lead to renal tubular damage. The air will pass into the circuit, lead to cavitation. Also, vessel will collapse around the drainage cannula and also the flow will fluctuate. A non-physiological positive pressure that will increase blood cell damage, increase the turbulence of the blood and shear stress. Another important value in the pressure in the circuit is pressure drop or delta pressure, which is equal to pre-oxygenator pressure minus post-oxygenator pressure. At this pressure, delta B is equal to pressure drop over the oxygenator determined by internal resistance within the oxygenator, which is inherent part of the oxygenator by manufacture. So if abnormally high pressure drop, it reflected to increase pre-oxygenator pressure and decrease post-oxygenator pressure. So to monitor the oxygenator, we will always see the trend between the flow in relation to increase the pressure. Any obstruction in the oxygenator will increase pressure in the oxygenator. This photo of prolonged use polymethylbenzene membrane oxygenator totally occluded due to cellular deposit on it. As a result of cellular deposit on the membrane, there will be increase in the resistance to the flow and decreased gas exchange. Another important part of delta B or pressure, pre and post oxygenator pressure, is useful to assess the internal resistance of the oxygenator. So we can measure the internal resistance of the oxygenator in relation to the blood flow through the oxygenator. If there is increase in the resistance due to prolonged use of oxygenator, there will be decrease in the blood flow. This is an example of ECMO console monitors, which summarize all what we mentioned before for ECMO circuit monitoring. For the first part is rotation per minute, and which reflects the speed of the pump and give certain flow in liters per minute. As we have fixed speed, we expect to have the same flow or slight fluctuation in the flow. If there is drop in the flow, we will start our troubleshooting. The second part is P venous or drainage pressure, which is a negative pressure. The third one is post pump or pre-oxygenator pressure. This is arterial or named post oxygenator pressure or return pressure. And is delta pressure, which is the pressure across the oxygenator. Also, the console can monitor the temperature for the blood through the circuit and mixed venous saturation of the circuit. This table summarizes significance of every pressure and its interpretation. So it should be memorized by everyone who works on ECMO. If we have, for example, P1 decreased, so we should go for knowing that this patient may have hypovolemia, increased interthoracic pressure, abnormal in-range cannula, or the patient may be awake. Very simple. Pump failure or air clot inside the pump will be reflected mainly by decrease the ramp or it's become equal and all these pressure will decrease. If there is oxygenator clots, so that will lead to increased delta pressure and increased P2. If the patient has abnormality in P2 and P3, so we should thinking about kink or clotting and the return cannula. Second part of ECMO circuit monitoring is the circuit efficacy. So, through the performance of the oxygenator and gas supply to the oxygenator. The first part of circuit efficacy is performance of the oxygenator. The drainage line of oxygen saturation kept more than 70%, reflecting oxygen consumption. False high pre-oxygenator will be due to recirculation. It's usually happened in VV ECMO, where the drainage and return cannula are too close to each other. Regional perfusion VA ECMO, whereas there is more oxygenated blood in lower body and there is hypoxemia in the upper part. Contamination with arterial blood occurs with LV venting and circuit drainage. So we can confirm this is performance by measuring oxygen saturation in and out, reflecting oxygen transfer. It's important to monitor post-oxygenator PO2 at least twice per day. PO2 more than 300-350 with oxygen saturation 100%. So if there is decrease less than 300, we can go for pre-oxygenator PO2. We can monitor the efficacy of the oxygenator every day by this method. Last part in circuit monitoring is circuit harm. We can detect consumptive coagulopathy or platelet dysfunction, hemolysis and free hemoglobin release, insufficient respiratory support. The table summarizes all safety things which are present on the circuit to detect any abnormality, like flow meter and pressure alarms, bubble detectors, and presence of backup battery. All of these are important while we are running ECMO on the patient. These are references besides Elsurik book. Thanks, and question can be posted in the comment.